So welcome to the April 7th, 2022 program of the Tucson Cactus and Succulent Society. It's always such a great pleasure to welcome back our good friend, Ernesto Sandoval. He is the director, manager, however they want to call him, of the UC Davis Botanical Conservatory. I'm sure that in his program, he'll show you some of the plants that he grows. He is a spectacular grower, and we've all learned a lot from his programs. Tonight, he'll tell you how to be more successful. So please welcome Ernesto Sandoval, and his program tonight is Feeding Succulents, How Fertilizer, Water, pH, and Soil Can and Should Be Adjusted. Ernesto.
Okay, thank you, Dick. And I think sound okay? Maybe it's a little loud, right? Is that better? Okay, yeah, just don't want to blow your eardrums out. All right, well, thank you guys all for having me. I drove down to LA yesterday with my family, and then from LA to here today. So glad to be here. And let's see, let me power this up here. And I think, just want to see if, oh, there we are. Okay, pointing. All right, yeah. Yeah, right. So how many of you guys acidify your plants already? Okay, good. Then I'm here to talk about the right thing to encourage you guys to help your plants some more, okay? Because basically what I'll show you at the end of this presentation is that with one watering of acidifying your plants, you will see that they will start growing much better, even without adding fertilizer, okay? So if you fall asleep during the whole presentation, just remember that one, okay? All right. And yeah, just let me know when you're ready to go, Brad. And by the way, I like questions as I'm going along, because usually if one person has that question, somebody else has it out there, especially in the Zoom world. I don't know how many people are watching over Zoom, but please raise your hands, call them out, and I'm happy to repeat the question and answer them as we go. And what else was I going to say? So while we're getting started here, this is the UC Davis Botanical Conservatory. It's a 3,000 square foot greenhouse. We have one of the most diverse teaching collections in the country, and we're particularly strong in the succulents. Great, thank you, Brad. And when I first started working here, most of our collection was potted indoors, but a lot of the succulents that we grow are for more temperate climates and even the Sonoran Desert, and they don't do well in a greenhouse. And so we've been growing a lot more outdoors. And over the years, I've started growing a lot more stuff in the ground, because I'm not going to touch on it too much here. No, actually, I think I am. I'm going to show you a chart how you basically torture plants in containers. Okay, so that's another something that I want you to take home today, is that when you keep plants in containers, you're kind of torturing them. And so there's things you could do to make their lives a little bit better, okay? So I don't want you to feel guilty as much as I want to encourage you to help them out. So we're good to go, and I can move forward here. Let's see. And I think, there we are. So here's the inside of the conservatory. Again, we're particularly strong in the succulents, but we actually have one of the best cross sections of the whole world of plants, because for all the teaching that happens at UC Davis. So it works out perfectly with my personality, which is a Jose of all plants, master of none. Okay. So I know a little bit about all the plant groups. I love it because I can talk to a bunch of different plant people, but I know that there are some of you guys out there that are more experts in a particular group of plants than I am. I sort of deal on the family genus level. So, okay, I think I'm well, I'll try to stay away from this clicker here. Okay, so this little chart right here shows you, it's gonna keep away the clicker so I don't hover that thing. Okay, so this just shows you basically how a plant generally works, okay? And what I want to point out is that underneath the soil, the roots, like this chart doesn't even tell you what's going on with the roots. But the roots, they don't do photosynthesis, okay? So the top of the plant does photosynthesis. That means oxygen goes in there and the plants do photosynthesis, and they take carbon dioxide from the air and make it into sugars. But down in the soil, roots don't do that. They don't do photosynthesis. They do the exact same thing we do, which is called respiration. They take sugars from the top of the plant, okay? And that's what our body, when we eat stuff and we process it and turn it into sugars, then we break it down. That's called respiration. Well, that's what the roots do. And what do we need to be happy from the air? Oxygen, right? Roots need oxygen. So one of the things I'm going to talk about is things you can do to improve oxygen to the roots, okay? And it's mostly giving plants a really good draining media, all right? So yeah, this is kind of the big picture of how plants work, okay? Roots, respiration only. The more oxygen you give them, the more water they can handle, okay? So if you like overwatering your plants, if you like giving your plants liquid love, okay, give them a better draining media and you're less likely to rot them out. But really, waters are a good resource that we should conserve, and succulents are great at it, so you shouldn't overwater them, right? Okay. But anyways, one of the things I just want to throw in here is that there are, I don't know if any of you guys giving you guys a lecture on cam plants that are only open up their stomata at night. Okay. Well, it turns out that some cam plants might not open up the stomata if the temperatures at night don't drop, if it doesn't get cool. And that means that if you keep your plants in a greenhouse that like cold nights, that maybe that's one reason why they probably don't grow for you very much. Okay. So anyways, I just thought I'd throw that in there. So what do roots need? Okay, because really I'm going to talk about roots today and their needs in association with the rest of the plant, but I'm going to sort of focus on roots. Roots are like people from San Francisco. They like it cool, okay? They don't like it hot, all right? I mentioned oxygen. They need oxygen, okay? So yeah, better draining media. And they do need a certain amount of water, okay? Many years ago, I had a talk with Gene Josephs here in Tucson about how Pachypodium brevicali were dying on him. And it turns out they were going too dry during the dormant season and roots were up and dying on him, okay? So he started splashing a little bit of water on him and the Pachypodiums were much happier. It's kind of cool if you take science and you use it, okay? Roots need nitrogen, right? Nutrients. And the big ones, nitrogen, phosphorus, potassium, and then the other sort of micro or medium important nutrients. And they need it for themselves and for the rest of the plant, okay? And I'm going to talk about acidification and pH, and y'all can try to memorize the sentence, or we'll show it to you visually a little bit later. But roots, to grab nutrients, they need a pH of about 7 or lower, okay? Because of the way chemistry works and the way acquiring nutrients work, a lower pH between like 5.5 to like 6.5 is much happier for roots, okay? Roots are much happier and they grab nutrients more easily, all right? So we'll talk about that. And then I just throw this in here just at the beginning, just to tease you with some general information. But basically, about 1 teaspoon, you need about 1 teaspoon to 2 tablespoons of vinegar, if you're doing it in small batches, for small scale growing per gallon of water, okay? To get to the right pH, depending on how hard your water is. And I'm going to give you more details a little bit later, but I just thought I'd throw that in there, okay? Okay, yes, this is the chart that I wanted to show you here. And we'll move through this really quickly. This was made for generally a leafy plant, but it applies to succulents as well to a certain degree. Okay, so a container plant, you water it. It goes from near saturation to the plant wilting in 1 to 3 days. You know, our succulents, typically it's more like 7 to 10 days, unless they're leafy plants, okay? They might be more on the shorter period, all right? In the ground, we call it field capacity to a plant wilting in 1 to 3 weeks, all right? This chart was probably made on the East Coast of the US, okay, but it kind of applies here too, all right? Aeration, the availability of oxygen or air to the roots, is low when you water it, to high when gravity pulls water out of a container. And whereas in the ground, if you have decently draining soil and you don't keep it moist all the time, which I assume you guys here in Tucson don't do because water is a limiting resource, right? It's adequate to high over the season. Okay, I'm in Northern California. We have a lot of clay soils. When people overwater their gardens, they are starving their roots of oxygen because clay soils have such little such small air pockets. Okay, nutrients high to low in a week or less, and in the ground it takes a whole season. Why do nutrients get used up so quickly in a container? Yeah, with the watering, you flush away the nutrients, right? And it's a limited volume, so there's limited access to those nutrients right away compared to a plant in the ground. Okay. pH can change 1 to 2 units in a week or a month because of mineral buildup, okay, including salt. All right. Salt is a particular type of mineral, but other minerals will affect the pH as well, whereas it's fairly constant in the ground. Okay. By the way, do you guys know what all municipalities, except maybe Flint, Michigan, in the U.S., adjust the pH of their water to? Anyone know? The pH in most municipalities across the country is usually between somewhere like 8 to 9. And roots need it more like 5.5 to 6. Okay? So we'll talk about why that's important later. Salinity, low to high in a container, and it builds up in a container pretty fast because of water with minerals getting left behind and salt building up in the container, okay? Whereas it takes a whole season for it to build up. And you guys know the caliche soils that you guys have in this area? That's because of like over, hundreds of years, thousands of years, a salt pan builds up and you get an impermeable layer. Okay, so it probably happens here a lot faster for you guys than it happens to us in Northern California. Okay. Look at this temperature in a container, 40 to 50 degree change in a day. And I bet you in your area here with the sun and the heat, it definitely, can happen pretty easily, whereas it's fairly constant in the ground. Okay, in the ground, if you go down just an inch or two, the temperature goes down pretty fast. All right, so plants in containers can really get overheated, and that can make it hard for roots to do their job. Okay, so disease susceptibility and susceptibility to challenges, much more challenging on the left for in a container versus in the ground. Do you guys feel guilty about your container plants now? Okay. All right. So we're going to talk about what you can do to minimize the abuse of your plants. Okay. And we do it for convenience, right? There's a lot of convenience to growing plants in containers, but I just want to show you that it's like 3 or 4 times more work to maintain plants in a container versus plants in the ground. Okay, I know that because we have like 10,000 potted plants at the Botanical Conservatory, and it's a lot of work. Okay, so this is the old mix that we had at the conservatory. And so I'm going to just jump ahead because we actually have a newer mix that I think is much better, okay? So what I want to point out, actually, I'm going to jump ahead. Here's some of the components of our old mix. And by the way, let's see if I can click down here and get in here. Just trying to get to the pointer here. There we are. Okay, the sand that you see up at the top, well, I have a hard time with this, but I'm just going to point out the sand in the upper left up there. We still use that a lot in our mix. It's number 12 mesh sand. Okay, and for mulching seedlings, I love that. Okay. Okay, good. I love using that, like when I'm planting seed, using that as a top dressing to trap moisture when I'm growing things from seed. We used to use it in our mix, but now I'll show you how we don't use it for that. But for germinating seed, it's a really great top dressing because it traps moisture, lets light in, so your seedlings start getting light right away. Okay. By the way, if you guys ever doing seed propagation, it's really important to pasteurize your media, whether it's 30 minutes so moist media, 30 minutes at 180 degrees Fahrenheit in an oven, or 5 to 10 minutes in a microwave. That's what it says there on the lower right. Okay. And if you're growing things from seed, you want to have semi-sterile, pretty inactive media, so you don't start getting things growing faster than your little cactus seedlings. Okay. Okay. And let's see if I can get it to click forward here. Ah, yes. That's the old mix again, but I'm going to click ahead here. Okay, so this is our newest mix that we have at UC Davis, and it's basically more inorganic than the previous mix that we had. Okay, I'm just having a little hard time with this clicker without getting the floater, the pointer floating here. Let's see. But okay, there we are. So our mix now is about 87% inorganic material, and you can see that it's mostly pumice. Okay, and by the way, this is by the yard, but it applies in parts as well. Okay, so 1 scoop, 1 bucket, or whatever. So 5.5 yards pumice, one part of the what's happened here? This is the red lava. Oh my gosh. That should. Oh yes. I'm sorry. Yes, thank you. I just caught myself here. The red lava there is just a little bit of red lava in the mix compared to our previous mix that had only pure red lava, because I found a good source of pumice. And so we have a little bit of red lava in there. I don't know if we need it, but we have it in there. Okay. Thank you. And you're controlling that, or am I doing that? No, it's me. Okay. All right. And then instead of using the sand, we started using decomposed granite in the mix there. Okay. Yeah, this it's really weird. It's not. I'm having a hard time like keeping it to point properly. But anyways, we started using the decomposed granite instead of sand because it's coarser and more jagged, and it probably doesn't bind up in the soil as much as the sand that's really smooth sided does. Okay, especially as the mix breaks down. And then instead of using peat moss, we now use coconut peat. Okay. And what's nice about coconut peat, it actually reabsorbs water when it's really dry, much better than peat moss. And that's why a lot of growers are using it, and it's more sustainable as well. Okay. And by the way, let's see if we, yeah, click forward here. Am I doing that? Okay, thank you. Okay, thanks. So what I wanted to point out is that pumice holds about 15 to 20% more moisture than red lava. Okay, we were using red lava before, and red lava was giving us problems because it probably dried out too much. And then on top of it, there's not a lot of information out there, but there's some there at least one paper that I found that talked about how when the pH gets to really acidic, 5 or below, there might be aluminum, manganese, and possibly fluoride toxicity. Okay, and some growers have talked about how they have problems with growing things in pure scoria or lava rock. Okay, and I say scoria because a geologist one time was like, "You can't say it's lava. That would be like melted flowing rock." So, all right. Question back there? Comment? I thought I saw a hand raised. Uh-huh. The dolomite as a pH stabilizer. Okay. It's a mineral, and by the way, we use it up north. I honestly, I'm not completely familiar with all the chemistry of it. So what it does in your climate versus our climate, how important it would be. Okay, with that's like the stuff that they use for paths sometimes, but it doesn't have a lot of fines in it. Or actually, because we use such little volume of it, it's about, I think, like 1/16 of the mix. It's not a lot of material in there that can plug up small pores. So even if it has some fines, it's not going to be much of a problem. Okay. Yeah. Let's see if I can do next slide here. Next slide, please. Thank you. By the way, so there you can see our current mix from the Botanical Conservatory with a Welwitschia plant there. you can see again, it's like, 87%, a really high amount of inorganic material with the pumice, and then a little bit of the scoria and tiny bits of organic matter in there. All right. And that means as the organic matter breaks down, it's not going to plug up your mix like most organic potting soils out there. Okay, next. So this is the problem with commercial mixes, is that they have a lot of organic matter, and they do that because it's cheap and light to sell. Okay, but the problem is with time it breaks down, especially in warmer climates like yours, even compared to mine, and definitely compared to the East Coast where these organic potting mixes were developed. Okay, you know how on the East Coast they're like, the summers are great, and then like 9 months of the year, in my opinion, it's miserable. Okay, in my opinion. All right, I'm not saying that's truth. I'm just saying my opinion. But anyways, the organic mixes are made for the quick turnaround of the nursery industry. Okay, and you guys heard of C&J cactus? Okay, they have an organic mix just like this. It's very organic for all the little succulents that they're growing for commercial sales, for oh my gosh, what's the word for it? Wholesale, for wholesale growing, right? Well, apparently they try to grow their stock plants, their mother plants, their large plants in the same mix, and they're having a lot of rot issues. Okay, and this is why us at UC Davis, where I got tired of transplanting some plants every year, I went to a much more inorganic mix to minimize the need to transplant things so often. And you know what? Our mature plants are very happy in inorganic mix. You can go pure pumice if you wanted to, and you'd be fine. It might slow things down because of lack of nutrient holding compared to having a little bit of organic matter in there. Okay, so especially for succulents, organic matter is not very important. Okay, next. So, and let's click through one more time, I think. Thank you. So, by the way, I have found a source in Southern California of some really good pumice, and I'll go in a second here. But I wanted to say that this is a really affordable way of getting pumice. Or do you guys have pumice available here pretty easily? Yeah, I'm very jealous of that. Okay. I was buying this stuff, the dry stall, for a while, but dry stall has a lot of fines in it. So then you have to go and sieve it. Next slide. There we go. Now I'm getting my pumice from a place in Southern California called General Pumice Products, and I get it by the pallet load of 50 bags, 20 to 25 to 30 pound bags, 1/8 inch and 3/16, and it's sifted and it's really good quality. Comment back there. The fines are just like anything below a millimeter in size or so. And what happens is those fine little particles plug up the spaces between the bigger particles. And even when we were growing things with a lot of pumice in it, it was still, for us, the way we grow plants, it was still holding too much moisture. Okay, so that's why we got the sifted stuff, and I'm willing to pay $13 a bag so that my plants are really happy. Okay. Yeah. So, but for the home grower, the dry stall, and if you were to take it and sieve it out, which is pumice, again, just to have some fines in it, if you were to sieve it out, you'll have a really good pumice source. Okay. And actually, I would dare say, one more before we go, I would dare say with your climate right here, having a little bit of fines that holds a little bit of extra moisture is not that bad compared to it is for me in Northern California, because you guys have such extreme low humidity and such long periods of warm temperatures, right? Okay, because you should always know that the author that's telling you about plants, where they're from, okay? And think about how their climate is different than ours. It's like when someone in San Francisco one time told me, you can take a plant the seedlings you're growing in a plastic bag and just pull it right out of the bag. And I thought, in my climate, and like especially with you guys here, that would be a drastic change in humidity. So, oh, next slide. So I want to show you right here some planter beds that we made at UC Davis using pure pumice. Okay, and I did this because I knew that the pumice would take a long time to break down, and I could grow my succulents in these like basically raised planter boxes for a long period of time. So they were planted in 2008. Next. And here they are 3 years later. Pure pumice. So what did I get here? One, I had a very consistently inorganic mix that didn't break down. Two, these plants, the plants were in a larger volume of soil, so it's no longer like a container, okay? It's really like a raised planter bed. These planter boxes are like 2 feet deep, 4 feet wide, and about 10 inches in the front and 14 inches in the back, okay? Next. And there the boxes are 8 years later. Okay, and we were adding fertilizer. Okay, we were adding fertilizer for a while. It was actually tap water with fertilizer, and we weren't even adjusting the pH. And then recently I went back to really good pure deionized water with fertilizer added to it. And I mean, look how happy they are. Next. Last slide to just show you how full and growing they are. Okay, and again, it's pure pumice. And really, again, now it's it's really like almost growing something in the ground because the roots have much higher volume of media, not soil, of media to explore. Question up here? So the question is in the pure pumice, some of the root feeding insects, is it harder for them to live there? And you must be thinking of like root mealybugs. And I don't think so. I think they're still plenty happy feeding on the roots. Okay. And by the way, we had major outbreaks of root mealybugs in our collection recently, especially with the transition from who did our pest control. So I've actually gone through like whole swaths of benches and drenched them with systemics to mitigate the damage that was happening to the roots. Okay. Yeah. Mealybugs are a real problem, but luckily they're not very resistant to pesticides. So one drenching, a good drenching, when the roots are growing really well, of something like imidacloprid, or there's some other stuff, will go a long way. So, and I like to do it where I water them with it. I don't get runoff, so I don't spread it, too much into the surrounding whatever. And then I water lightly for a week or so that it stays in the soil and gets mostly into the plant. And I will not do it outside on plants that are going to get visited by bees. Okay. Yeah. Any other questions? Okay, next. What I just wanted to throw this in here because many years ago I did a lecture. I was doing a lecture on potted plants, and I was talking about transplanting, how improving the soil quality, etc. And then everybody, as they were leaving, I was doing this lecture in October in Northern California, and they were like, "I'm going to go transplant my potted plants right away." And I thought, their plants are going dormant right now, and I just told them how to make them better, but I should have told them to wait till spring. Next slide. So generally you want to mess with your plants, pruning or transplanting when they're beginning or actively growing. Next. So for container plants, it's usually sometime from early spring to midsummer, but again, this is for Northern California that I put this down here. You guys have a much longer warm growing season, right? Oh, did I just back that up myself? Okay. As long as the plants are growing, you could mess with them. Next. Okay. For leafy plants, you can sort of do them through summer. Next. But for all your plants, really what you should be doing is stop messing with them at least a month before the temperatures cool down or the plant goes dormant. Okay. So you want to mess with your plant while it's actively growing or it's starting to grow, but you want to back off and avoid, as they're going dormant, because you basically want them to recover from wounds and damage before they shut down and don't heal. Okay. And I can make analogies to like humans and health and things like that, but I won't. Next. Okay. And by the way, in Northern California, we do a lot of planting of natives in the fall because we have mild winters. And so, plants going in the ground that are going to grow through the winter, plant them in the fall when you have a little bit of cooler temperatures and they can get established before they grow, they get hit with the summer drought. It's a good thing. I mean, you guys have some summer rainfall, right? but it is erratic. But you know, planting in the cooler, again, if they do grow through winter, is a really great way of establishing things. Okay, but I won't, you know, I won't tell you what to do here in this climate as much as somebody else here locally could. Okay, next. Okay, transplanting. One of the things you want to do is make sure you don't give things too big of a pot. Next. I think you can click like 2-3 times through here. Um, yeah, let's click 2 more times through. So and once more, please. So when you have a potting media, especially if it has a lot of fines in it, or you know, organic matter, you will get something in the bottom of your pot of your container called a saturated zone. Okay, and it's a combination between the sponginess of the soil and gravity pulling the water through. And the finer the mix you have, the thicker of a sponge you have in the bottom of your container. All right. And you don't want to put something in too big of a container because you'll have a big giant wet sponge in the bottom of your container. Okay. So next. So in general, what the suggestion for succulents is, I don't know why it disappeared, but there we go. In general, you don't want to have more than 1 inch on the edges of your container for your succulents, especially if it holds any amount of moisture, because then you have too big of a volume of media. Okay. I'm gonna see if I can click through here. Yeah. Okay. So yeah, succulents and low water use plants should get no more than about 1 inch of a gap from the inside of the pot. Okay. I don't know how that happened. I'm gonna click off of that because this is it's giving me trouble. I'm sorry. Could we click through a couple more times? And by the way, yeah, let's click through till it takes about 4 or 5 clicks in here. Sorry. Let's just click all the way through. Forward. Thank you. Sorry. There we go. And let's just click all the way through till you see the big circle with it. Don't do it. Okay. There we go. So here's what happens when you put a small plant into a big container, especially a low water using succulent. Okay. You'll have a big mass of media, and where it's the plant is not going to pull the water out of there before fungi and bacteria start growing in there. Okay. And I liken this to anybody here, the person or know somebody that leaves a wet sponge in the sink? Okay. All right. You know, I'm at Davis where I talk to undergraduates a lot, and like, you know, they have like housemate issues, you know, you know, people in the door and learning to live with each other. And so anyways, you know, I had the housemate that left the wet sponge in the sink, and what happened to that wet sponge? It turned moldy and stinky, right? And broke down. And so you should always like take that sponge and squeeze it out and then set it back down, and then it'll air dry the rest of the way, right? Well, if you keep your potting soil moist all the time for your succulents, you're going to promote fungi and bacteria that are then going to move into your plants. Okay. And that's why you don't want to do that. And by the way, I showed you guys where did you guys saw the slide where I had like something in there, like a little like divot in the container? You guys ever seen the containers that have the little shape like this in the bottom so that it's not completely flat across the bottom? Okay. Because of the way the saturated zone works, it's a volume at the very bottom of the media. And anyone heard of how you could put stuff in the bottom of the pot to increase drainage? Incorrecto. Okay. When you do that, you're just basically taking that wet sponge and you're elevating it up higher. Just like if you have a wet sponge in your hand, it could be like in your hand or on the counter, it's not going to drain out. So if you ever want to put stuff in the bottom of your container to increase drainage, what you want to do is you want to mound it up or make it like this. But basically, don't go all the way straight across. Even at an angle, you basically want the soil to connect all the way, the media to connect all the way to the bottom of the container so that water gets channeled down there because of gravity. And so the less volume you have in the bottom, the better. Okay. So really nice pots have like something like this, or you know, anyways, where this media connects to the bottom. Okay, next. Okay, let's talk about container gardening a little bit more in details and ideal containers. Okay, does this happen around Tucson at all? Somewhat, right? Okay, okay, next. So let's talk about what makes a container. Next, almost anything can be a container. One more again. This is for the mobile gardener. Next, this is for the tired or retired gardener. You might be thinking, Ernesto, tread lightly. Okay, next. This is for the potty mouth gardener. Okay, next. So, oh, by the way, which of these is the crappiest of all containers? Ooh, John Crapper got a bad, Anyways, this is the terrible one, right? The toilet, because the hole for that one is actually back up here, right? If you guys know how toilets work, water gets dumped in there and then it creates a siphon and gets sucked out of there. And so that there's no hole in the bottom. So at the very least, you should have a drain hole so that water can drain out, right? Because those marigolds that are in there, they're getting moldy and gross in there, okay? And there's this whole thing called Instagram where people are like showing off their plants and how they grow them. And you see a lot of people growing succulents in containers without holes in the bottom. And to me, I'm thinking, ooh, how long will that last? Okay, next. So, what makes a good container? Next, please. Ideal container should look like this, okay? It's, next, taller than it is wide, next, and narrows at the base to decrease the saturated zone, okay, again, and it's filled with the right mix for your plants, okay? And I have a student that works with me now. He loves pumice. He takes our succulent mix and then he adds like another equal part bag of pumice. So now we're like at 90% pumice. And I know that over time, what I'm going to find out is things that like a little bit more moisture. Like, for example, I have this like dendrosicyos right here, a cucumber tree. This thing, I water it like 3 times a week compared to like the euphorbias don't have any leaves on them. Okay, and I know that this plant, I mean, as happy as it is in pure pumice, it'll be perfectly fine with not having so much high volume of pumice in a container because it grows so fast. So the faster they grow, they don't need, because they suck up water out of the container, they don't need as much pumice. And so we use different different combinations of media for the different plants they would grow. Okay. And we grow a lot of non-succulents as well. So we have other components. Next. So look at this. Oh my gosh, those are the wrong containers. Okay. This is actually Plants for the Southwest, Gene Joseph's and his wife's nursery. Look at how he has this little bonsai container that is growing the sparrow cactus in. All right. And I was talking to him when I was there. It's actually quite a few years ago. And I was asking him how he dealt with water and watering the plants the right way. Because a pharaoh cactus like that one right there is not going to wilt. So how do you know when its roots are not happy because the media is completely dry? And the hint is, see that little poppy that he's got growing in there? That's his moisture meter. Because especially when you have top dressing, it's harder to get your finger in there to feel the moisture. All right. And again, I was having this conversation with Gene about his Pachypodium brevicalis, and he was having them up and die when they were dormant in the middle of wintertime. And, we were sort of talking back and forth about it. And he's like, I just got so fed up with them dying on me in the middle of wintertime. I decided, what the heck? I'm going to splash a little bit of water on them during the dormant season. And lo and behold, his plants stopped dying on him as much. Why? Because in a container, the soil was going completely dry, and those succulent fleshy roots don't experience that often out in nature, where it's like completely bone dry, and that's when they do die. That by giving them a little bit of moisture, he was keeping the roots just a little happy and not bone dry, and they weren't dying on him. And you know what happens with the succulent? Something happens with the root where the roots die, and then in a day or two, the plant is a complete mush, right? And that's what was happening to the Pachypodiums. So to keep the roots happy of like this sparrow cactus, he introduced this little native poppy that when that poppy is wilting, he knows that the media is really, really dry and it's time to water his plants again. And so that's what I do. I have a few plants in my collection that don't die but wilt, Pereskias and a few other things. And then once a few of those are dry, I know most of my plants need water. Okay, pretty good idea, right? Moisture meter, because especially when you have a lot of pumice, it's hard to jab this thing too far down there, right? The finger. Okay, next. Just really quickly, the coarse of the mix, the less of a saturated zone you have, the finer and finer you get. And by the way, when you buy a potting soil that has a lot of organic matter, it starts off like on the left there, and it works really well. And then with time, it breaks down and becomes more like the media, like the on the right, and you have a bigger wet sponge in the bottom of your container. Next. Thanks for doing that, Ben. Appreciate that. And again, see if you put junk in the bottom of a container all the way across, you're basically just elevating that wet sponge. Next. Okay, and again, that's why narrow pots decrease the volume of at bottom of a container that saturates it. Next. And that's why, like, sometimes if I'm going to put stuff in there, again, I'm just going to put it on a little bit of mound to basically take away the volume. Someone a while ago said, what if I just put a few big rocks in the bottom of there? Hey, that's okay if you're okay with your pot being heavier, and that will work perfectly fine because you'll take away volume down there. Okay, but the media connects all the way to the bottom, so you don't pack them tight. You make it so that the media can work through between that. Does that make sense? Again, because it's gravity pulling the water out, and then the media being a sponge and holding on to it. Next. The height of the pot doesn't affect the saturated zone, but the one on the right, that's a really tall pot, will be drier up at the top because it's sort of a transition from very saturated at the bottom to drier at the top. Next. Okay, and let's just click through to the next slide. Okay, next. Yeah. Oh, sorry. Can you click through this? I forgot to shut down this duplicate slide in here, and we'll just click through until we get to the proper slide here. I'm sorry about that. So in case you guys want to revisit this, okay? All right. So don't do that. Too big of a container. Okay, great. Thank you. More on roots actually here. So next slide. Next click. Sorry, click. By the way, clay and wood containers insulate the roots from the heating of the sun, versus the plastic pot does not insulate, right? All right. And do we all know what makes a good insulator? A woven material, or material that has air pockets in it. And that's why a clay or a wood container that have little air pockets in there make good insulators. Next. With afternoon sun beating on a plastic pot, in about half an hour, the temperature gets up to 140 degrees Fahrenheit. That's like twice what roots normally like, right? And by the way, the note on the left there, high-fired ceramic pots, even though they started off as clay, because they got high-fired and that clay got basically melted, you actually squeeze out all the air pockets, and those really beautiful pots that we all use in our collections actually don't insulate the roots very well. So it's really important to keep them from having too much direct sun beating on them, especially in the afternoon, so you don't get roots heating up too much. Okay, and that's why a lot of people that grow display specimen plants grow them in situations like where shade cloth is there to keep direct sun from beating on the plants, whether the top or especially the containers. Does that make sense? All right, next. Okay, so how to prevent salt buildup, because a lot of people grow plants like on windowsills, etc. Next. And so, I only ever use trays underneath my plants when I want to prevent from doing damage to some the surface underneath. Okay, counters, windowsills, etc. Outside, never use a tray. Okay, and next, you want the water to drain out. So what I do when I do have plants in trays is I'll put like some kind of coarse material to basically elevate the plant in the tray, so that when water goes through, fertilizer or tap water goes through, it goes through and drains out, and it doesn't make a connection, so that that moisture can't get pulled back into the container, because over time you're going to get salt buildup in the bottom of that, right? So you want to elevate your plants in your trays when you do have them in trays. Okay. And then under that situation, très bien. Trey again, yeah. Okay, next. Thank you. So yeah, elevate the plants to prevent wastewater from being absorbed back into the container. Next. At home, I grow some plants on my windowsill, including like Welwitschia, and I use a very dilute amount of water-soluble nutrients, or just the just RO water, and so it's very pure. So I don't have to worry about salt buildup. But that's why like people that use rainwater, you don't have as much problems. Next. Okay, now we're gonna get to the chemistry of the whole thing and pH. Okay, anyone ever seen this chart before? Okay. I finally saw it when I took a container media class at UC Davis, and it took me a lot of hunting on the internet to find a copy of this. Okay, and I did get permission to post it, to use it. So what this chart shows is the various nutrients from most important to sort of lower to micronutrients at the bottom, and how their availability is affected by pH. All right, and you can see that when things are very acidic, they're unavailable, and many of them, when the pH gets alkaline, they're also unavailable. And the sweet zone is somewhere in the like right in here at 7, but honestly, because of our media oftentimes has minerals and salts in it, you want to start off between like 5.5 to 6, so you can get it to about 6.5. Okay, so next. Okay, so that's that chart that I just showed you. And on the right, that's not even a root right there, okay? That's a root hair. Okay, one little root hair on a plant. Next. And soil and organic matter are negatively charged, okay? Next. So it's a very negative world out there, okay? All right. And I'm gonna show you guys how roots literally make the world a more positive place, if at least in a chemical sense. Okay, next. Okay, so yeah, we can just click through until you get to magnesium, iron there, or boron. Yeah, there you go. Let's stop there. Let's stop there. Can we back up one? So nitrogen is available in 2 forms to plants: ammonia, the one with the NH4 plus, and nitrate. Okay, and then phosphorus is negatively charged. Okay, and this is why phosphorus and nitrogen are very limited to plants in the environment, because they're negative, and the organic matter and soil are negative, and they wash right through the soils. And this is why having those large feedlots that are generating lots of nitrates, and then those get, with rainwater or moisture, they get washed into riparian areas or estuaries or whatever. They don't lock up in the soil. They build up, they get transferred to water areas, waterways, that then get over abundance of these compounds, right? Whereas like, potassium positively charged, sulfate is negative, and then calcium, magnesium, iron, and manganese are positively charged. And so those nutrients will bind up into the negatively charged soil and organic matter. And by the way, this is why it's better to give your plants ammonia versus nitrate, because ammonia gets locked up into the soil, and then the plants can absorb it. Whereas nitrates just wash right on through. Okay, next. So yeah, plants literally make the world a more positive place. Next, by making it more acidic, by they generate what we call protons, positively charged acids. Next, and they dump them out into the environment. Next, and they literally make it more positive. Okay, and when they do that, it's called acidification. They pump those out there, and by making it more positive out here, it loosens up those nutrients that are locked up in the negatively charged particles, and then the plants can absorb them. Next. So pH is a measure of that. Okay, when you have when the conditions are more acidic, there's more in the water. There's more H plus than there is what's called OH minus, which is alkaline. Anyways, when there's more of this, it's called basic, and there was more H plus, it's acidic. And when it's acidic, because it's more positive out there, it's easier for the plants to grab those nutrients. All right. And something like iron, you could have lots and lots of iron in your mix or your soil. But if the pH is alkaline, the plants aren't going to get it. Okay. There could be a lot of it there, but it's chemically unavailable to them. And that's why we like, especially with like acid loving plants, we talk about chelated iron. Okay. If you've heard of that, it's a form of iron that's not chemically, not influenced by pH. Okay. And by the way, do you guys know what pH actually is? It's actually it's a logarithmic measure of the H plus. Okay, and basically, so if you have a pH of let's say 6.5 or 7, which is the happy like neutral. All right, if you go to pH 8, that's a 10-fold difference. Okay, that's 10 times. So if you go from 7 to 8, it's 10 times more alkaline than it was. Okay. If you go from 8 to, and then if you go from 7 to 9, that's 100 times different because each number is 10 times more. So two whole numbers is 100 times more. And so think about that. If your plant's like 6.5 and your municipality makes the water 8.5, your plants have like have 100 times more challenging situation to grab the nutrients. All right. That makes sense? Okay. We can have a longer class on acidity if you'd like. No? Okay. Okay, next. So, by the way, how do you acidify, okay? Well, like I said, with low mineral water, like we have in Woodland Davis area, because we get water from the Sacramento River now in our area, it takes about 1 teaspoon per gallon of water to get to the right pH. People in San Diego that get water from the Colorado River that has a lot of minerals in it by the time they get to it, because half the water evaporates in the air, right? Okay, the water is very mineral rich, and it takes about 2 tablespoons per gallon of water. Okay, citric acid is another form, another thing you can use to acidify on a small scale or larger scale. But what I want to say is that that's sort of ballpark estimate over there. Okay, anyone here acidify? Someone back there said they did. Someone here in the room said they did earlier. Anyone else do acidification? Yeah, do you do vinegar? White vinegar? How much do you use per gallon of water? Okay. Okay, yeah. So he doesn't even measure, but he throws a little splash. It's probably somewhere between a tablespoon and and 2 tablespoons per gallon of water, and that knocks his pH down on the acidic side. And you guys have pretty mineral rich soils, and anyways, the water's pretty mineral rich, I imagine, and so it's a little going to be hard to overdo it rather than not doing it at all. Okay, you make a tea from coffee grounds. What I'll tell you is that it turns out coffee grounds, when you run it through the coffee maker, the acid in there is so water soluble, you're drinking most of that acid, and there's not a lot of acid left in the coffee grounds. Okay, so drink some of it and then give them a splash. Okay. All right. And yeah, regular white vinegar is the right thing. Really, what you should do if you want to do it more scientifically is get a pH meter. And by the way, you can get these on Amazon for like $26 nowadays. Okay. And you guys probably have the water's pretty consistent throughout the year. For us, it changes depending on the season. Okay. In Northern California. Is it pretty consistent? Yeah, I imagine that it is, because the source water is probably pretty consistent, right, for you guys? Yeah. And again, municipalities, and I mentioned this earlier, even though, anyways, Flint, Michigan, the reason why they had problems with the water there is that the city changed the quality of the water that they were bringing in, but they didn't adjust the pH to the alkaline side to keep the pipes from corroding and breaking down. And all municipalities do it. Even if the water is pure, they still bump up the pH to like 8.5 to 9 to keep things from being degraded from the pipes and then us drinking it. Okay. And so even people that have really clean water, and even people that have water that could be acidic, like in Seattle, Washington, they still need to do this to get the water for their potted plants because the water is going to be alkaline. Okay. And it's going to be, and like I just showed you, it makes getting nutrients harder. So by acidifying, you will fix that problem. Next. So I'm going to show you a couple of examples of situations where a couple of friends of mine did it at home. Okay. And Barry Rice is a friend of mine, Davis, that he used to grow carnivorous plants, but he lived here in Tucson for a while and his carnivorous plants slowly died out and he became more of a succulent supporter. Okay. But this is actually in Northern California now. So he was having some of these plants that were just up and rotting and dying on him. Okay. And he was watering them with tap water. And then when he acidified it, at the end, I'll show you how he has a lot less problems. Next. So what he did is he used this famous paper that's really commonly known in the succulent world that was published back in the CSA, I guess in 2010. And a lot of people have copies of it. Barry has it on his website right there. Malcolm and Burley. They go through this. They went through this whole routine of deciding how much to acidify the water. And what I'll tell you, those of us that understand the science behind acidification, these guys, their justification was not very scientific, the way that they did it, but the practical aspect of getting the pH on the acidic side is totally spot on. Okay, so the reasoning behind it doesn't make sense technically to me, but the practical aspects of acidifying. So next. Barry used what these guys, Barry is like one of these people that likes things like very lined out. And so we went with what these guys suggested in their paper. And by the way, that's his mix. 4 parts pumice, 3 parts crushed granite, purely inorganic. And then he uses the Dynagrow that these guys recommended. And this is the recommendation for the home grower is about 50 parts per million nitrogen. Okay, it's basically about a quarter strength. If any fertilizer that you get, it would be a quarter strength of what they could recommend because they typically recommend about 200 parts per million. Okay, and you don't want your plants to go on fast forward. You just want them to grow well. So quarter strength fertilizer is pretty good. Okay, next. And so this is all sort of his justification. Here are his notes to get to what he was doing. Okay, but basically he's trying to get the combination of fertilizer and the pH to about 5 to 5.5. So it's pretty acidic. And then by the time it hits the mineral-rich media, it lands at about 6.5. Okay, so that's why you go a little bit low, so you can get it to the right pH once everything's happening with the chemistry in the media. Okay, next. And look at this. He bought himself a really nice pH meter, and he's got all his stuff here. His graduated cylinders, so you can get it all perfect. And basically, what I'll tell you is, and I'll repeat this again, is that he basically adds his fertilizer first, and then he adjusts the pH. Okay, and he's doing it on a relatively small volume because he's got a small area that he's growing in. So before we switched to river water in Northern in Davis, Sacramento area, Davis Woodland area, he used to have had 200, basically about 300 milliliters of 5% vinegar per 30 liters of water. So that's how much he's making. But now he only has to add 50 milliliters. Okay. So if you ever get better quality water, cut back on the splashing. All right. Okay. Next. And here's a bunch of his plants. He grows these beautiful Aerocarpus, and he's actually doing some really great hybridizing of Astrophytum asterius, and you may have seen some of his stuff for sale on eBay. Next. But he's basically saying once he started acidifying, rot is a thing of the past for him. Okay. And so, those are all he just put this in here to show you that he's having really good success. And just, most of the plants like it, like basically all plants like it acidic because of the chemistry that I showed you earlier. All right. Even things that like more alkaline soils, they typically do better even still with calcium. With acidification. Okay. Next. So this is one of the ways that some people do it on a larger scale, like at the Huntington. they use what's called a portable a nutrient injector. In this case, it's portable. It's made on a hand truck. Okay, this is at the Huntington down in LA. Next, and the dosatron here, if you want to get good quality nutrient injector, the dosatron is the way to go. Okay, that's like the Ferrari of nutrient injection. Next. Okay, and by the way, if you see what you do, if you ever get one of these, you want to have a filter on the like one of those 200 mesh filters in there, so you don't get any particles that are coarse enough to scratch up the inside of that and ruin the seals on this thing. Because the way these work is actually really cool. The water causes the pumping that then siphons it out of here. Okay, and you have it. You have a certain mixture concentration in here, and then it gets diluted by being sucked into that. It's called a proportioner, and then it gets shot into the water stream and goes out to your plants. Next. So this is the second best option, mixed right. Those cost about $400. These cost about $250. And then I'll show you the $120 model that the student that works for me bought off the internet and the challenges that came along with it. Okay, in a second. So you can get them. You can get them for about $120 on Amazon, made over in Asia, and to lower quality standards. And so he has like leaking problems basically with it. Whereas the dosatron, they're beautiful machines. Okay, next. So this is as I finish up here. So Gianluca, the student that works for me, that's doing wonders with our succulents at the conservatory at UC Davis. This is the one that he bought on Amazon, and what he had to do is he had to repipe it so that he can basically shut the water off to here, because if he had it under constant pressure, he would get leaking from his nutrient injector. And he did everything he could, and the thing was cheaply made enough that he had leaking, so he just put in bypasses to shut it down when he's not using it. Okay. Next. So by the way, the pH started at 8.5. And he got it down to 5.5, like Malcolm and Burley suggest, by using a 2% dilution ratio in the injector with he's using phosphoric acid. So he gets about from this. I think it's next. Click through here. One more. So he makes 40 gallons in here, and he's using phosphoric acid. It's 600 millimeters of phosphoric acid to get the pH right. I know somebody one time, they were told me they used hydrochloric acid, and that's a very strong acid, and it was something like a drop of it per like 50 gallons. Okay, so don't do that. Use a safe acid like vinegar. Phosphoric acid is not very strong also. I was using it for a while in my greenhouse. I was using citric acid because I could buy 10-pound bags of on Amazon. And I could like dump it in there, and I could stick my hand in there and mix it. I wouldn't do that, okay? But I could, it was citric acid. It's a very weak acid, so it's not very dangerous, okay? So, and this is what Gianluca said, that with one, and this Barry said the same thing, and everybody else. Back over there, with just 1 or 2 waterings, did you notice your plants growing much better? Right? Yeah, just 1 watering, because you got the pH right. And even if you didn't add fertilizer, I had this with my leafy plants at home when I just was doing acidification with sulfur because it was constantly moist, and sulfur works under that way. But you use vinegar and diluted and liquid acids because then every time you water, you're acidifying. With 1 watering, you notice differences. Okay, back there. It probably should work in the ground as well. I would just be concerned about doing it at home if I'm anywhere near the structures and concrete that I'm going to start degrading by acidifying too much. Okay. Yeah. Next. So thank you very much, and I'll entertain some more questions as we're going along.